today we'll be looking at the 3.6 kilowatt solar hybrid inverter. This kind of configuration is called the grid assisted hybrid inverter system. You can see the capacity here, 3.6 kilowatts, 24 volts, and we have can use it for also PV. PV means photovoltaic, that is the solar panel parameters. It has an operating voltage of up to 240 volt DC and a voltage range of 90 to 500 volt DC. So this PV unit can accept as high as 6,200 watts, even as it is rated as 3.6 kilowatts. So we get more output from the system if you are using the PV, that is the solar panels. So for the grid output, this is just general information. Then we have also two load outputs on this particular system, so you can separate the load based on what you want. We'll be looking at the installation for the input side. Here we have the AC input section. Right here we have three components here. Here is the meter, digital meter that we use to check the amount of voltage, current, and the watt hour supply from the grid. On this second part is the 40 amp miniature circuit breaker for overload and short circuit protection, while we have the voltage and current relay to control the amount of voltage and current coming into the system. This is programmable. You can set a limit for the voltage, the current. Then the other part now is the battery section, where you connect the battery from the inverter down to the battery. Here we have two 12-volt battery. The 12-volt batteries are connected in series to give us the 24 volts which is required to run on this system. So right here now you can set the voltage, low voltage, high voltage, and high current on this particular system. So here is for surge protection. It's used to protect against transient voltage and current. When I say transient, it's a voltage that can happen in milliseconds, that's millions of a second. This type of voltage most times are extremely high, but it happens in a very short duration of time. So what this does is it clamps that excess voltage, then the excess current is drained out through the earthing cable to the earthing bar. So this is for the input protection. Then here we have the battery input and output. This particular breaker is the 125 amps DC breaker. It controls the amount of voltage going in and coming out because it is a bi-directional system. When the system is charging, current flows into the battery, and when it's supplying, it discharges and send current back to the inverter. DC comes in here, then sends AC to the load. So here we have the whole system. Now right now there is no supply from the grid, so we are going to power up the system. Then the battery itself, this is a 12 volt 220 Ah tubular battery. It's also called the flooded lead acid battery. This is an Indian technology. They make very good batteries, and this has been serving its purpose very well. It has a backup time of 3 days. If it is fully charged, it can take you for 3 days regarding the number of the batteries. So if you have more battery added to the system, it's going to increase the number of days also. Here we have a solar panel which is going to be installed later on, maybe in the coming days. This is a 550 watts solar panel. If the customer has gotten more panels that is required to power the system, we are going to integrate it to the system. So for right now, we are just doing the grid assisted solution, which can later be upgraded to the off grid, which is the solar panel. So right now, as I said, there is no power from the grid. So right now we're going to power from the battery. So we'll switch on this, then we'll flip the breaker. The system has been powered on now. So if you look at the screen, you will notice that this is showing red. When it's on backup, this shows red indicator. When it's on grid, it shows blue. That means that's the charging stage. Then when it's on solar, it's going to show purple. But right now it's on backup. If you now come to the screen, you notice that we are getting supply from the battery. You see the arrow pointing up towards the blue box, which is the inverter, and which directs to the house icon, which is the load itself. Right now is supplying 23.6 volts directly to 230 stable voltage, 23.7 volts from the battery, which is now converted to 230 volts AC. This is DC voltage converted to AC, which is the work of the inverter. And you can see the current load being supplied now is 61 watts from the system. If you look at now, you can see the light bulb. The light bulb is on. This is supplied from the inverter system itself. All the lights here in the sitting room. You can see the TV is showing. The home theater is on. You can hear.
I'm not leaving here without my son's lobster.
So every other thing can be powered on also, like the fridge.
Like the fridge.
You can see this also powering the fridge and every other thing in the house. This is 3.6 kilowatts, as I said, so it can power so many things.